Right, so we're still on subnetting IP networks. All right, so from the previous week, okay, we have actually reached the end of the subnetting for slash 24, right? Slash 24 networks. Okay, so in the session this week, we're going to look at the slash 16 and slash app subnetting. So that's basically just mean we are doing the 16 bits network part and 8 bits network part, right? So the technique are the same, but you will be dealing with larger values, okay? Larger values in terms of the hosts, right? Number of available hosts. So before we proceed, just as a recap, we watched this video about two and a half minutes, yeah? Okay, so it's based on slash 24. So we look at it, we refresh our understanding, and then we tackle the slash 16. So for now, let's do this first. I will start recording after this video.
In this situation, we need to create 8 equal size subnets starting from the 192.168.1.0/24 network. We actually only need to create 5 subnets, but since subnets are created in powers of 2 starting from 2, we'll need to create 8 equal size subnets in order to accommodate the 5 subnets necessary in this diagram. So first, I write out the subnet mask in binary, 24 ones for a /24 network. We're going to borrow bits from the host portion of the subnet mask. If we borrow 3 bits, we've borrowed 2 to the 3rd power of bits, and 2 times 2 times 2 is 8, so this will create 8 subnets. The last one in our new /27 subnet mask is in the 32's place if we look at it according to an 8-bit binary conversion table. So the last bit is in the 32's place. This lets us know that the subnets will go up in increments of 32. So the first network will be the 0 subnet /27, and the next subnet will be the 32 subnet /27, and then going up in increments of 32. 32 plus 32 is 64, and then the 96 subnet. After 96, we'll have the 192.168.1.128/27 subnet, and then the 160 subnet, the 192 subnet, and the 224 subnet. So as you can see, we have 8 subnetworks going up in increments of 32, the 0, the 32, 64, 96, 128, 160, 192, and 224. We can use any of these 8 subnets to accommodate the 5 subnets that we'll need to address all of these networks.
Sir,
Yeah?
is that the magic number?
Yes. The magic number is always the last bit position of the borrow bits. Okay? So that means the magic number is, let's see, can't see here, 32, right? 32 previously. So depending on which position, the last bit that we borrow, that will be the magic number. That means the value, the decimal value of that bit position. Okay. What do we use the magic number for? So that we know the next subnet. We always start with 0 because we are given the first address is box 0, right? So next one will be with magic number 32. And then you add 32. How many subnets you create based on how many bits you borrow. So three bits borrowed, 2 power 3 is I think 8, right? 2 times 2, 4, 4 times 2, 8. So 8 subnets. What the guy was saying is that because you are doing doubling, right? That means based on the power of 2, then there's never going to be the exact match. Sometimes if you happen to meet the subnets that on the correct doubling of the number of subnets, then that's fine. But usually, most of the time, it's in between somewhere. So you have to find the next larger subnet numbers that can actually accommodate your requirements. Okay, so sometimes in between those doubling of subnet. So usually, if we have extra subnets, then we use them for future needs. That means if you want to expand your network, you want to add, at least you have spares. Okay. The one is you cannot because you cannot reduce any longer. No more reduction. That's the best you can do. Right. Okay. So basically that was /24 boundary address you're given. Right. So in the coming session, we're going to look at /16, which is class B, right, from the class 4, and then /8, which is class A or class 4. So which means if you're given a address, okay, you're given a network address, right, at /16 network address, then you want to subnet from there, okay, or you're given /8, and then you want to subnet from there. That means when you borrow bits, yeah, that means you definitely get more space more space for increase of number of subnets because you got more bits, right? And also definitely increase in number of, even though when you borrow the network part bits for the network part, you still have a lot of bits for the host, right? So that means if you look at /24 and you want to subnet there and it does not fulfill your need, then you have to think about maybe I should start from /16 network. /16 because you have 16 bits for host. That means you have more bits to borrow and more bits also per subnet, right? Okay, so let me just record first session. Right, so as I was saying, yeah, the technique to do it is still the same. It's just that the numbers, the values will be larger because of the more number of bits available, right? So as you can see here is /16. We start from /16, and it's the 2 octets belonging to the network part, 2 octets belonging to host part. Instead of starting from here, /24, we start from here. So that means we borrow bits starting from here. So you can see this table is showing you, okay, all the different prefix length, starting with borrowing 1 bit, 2 bits, 3 bits, 4 bits, and so on. And you can go all the way to 30 actually, right? Okay, as you can see, because we have more bits, the difference with /24 is that you're now dealing with larger values. Okay, you can see there, borrow 1 bit, number of hosts per subnet is about 32,000, right? But you can see that as this is being reduced as the bits is borrowed, okay, the number of subnets you can create increases, right? Okay. Right. Again, still the same. Borrowing 1 bit, the formula is still 2 power n being the number of bits borrowed. Okay, and you get the number of subnets available to you. Right. So as you can see, because it's doubling here, your requirement might not fall exactly on the number of bits that you create by borrowing the bits. Sometimes it falls in between. So your task is you have to find the next larger number of subnets that can accommodate. Okay, so let's say I need 18. Even if I need 17, this one cannot support already, right? So you need to go the next. Even though maybe you see, oh, 32 minus 17, there's still a lot of subnets I'm not using, but you got no choice. Huh? That is the fix already because of the binary numbers that we are using. Yeah. So as you can see here, it's an example of we borrowing 7 bits. Yeah. So the thing is, when you just look at this part /23, you will not know whether it's plus 16 plus 8 or plus A, B, or C. Okay, so in order to get a proper understanding of this /23, you need to know what's the original network address. Usually, you're given in the questions, you are given the starting point, which is the network address that you need to subnet. Okay, and from there you work your way. Okay, so usually you're given a /16, then you start from there. So even if /23, you know, because you start from here, you know that it is yes, you have borrowed 7 bits. Okay, because if you start from /24, okay, let's say 23 maybe it's not that obvious, but let's say this is /25. Okay, without knowing the original network address, you wouldn't know whether you're starting from here or here. But in most cases, or every cases, you will be given the original network address. From there, you can know whether it's the slash is borrowed from which octet. All right, so very easily, if you want to know if I borrow 7 bits, the formula is 2 to the power of n, right? Will give you the number of subnets. Okay. Right. Okay, so that's the formula, right? For hosts, very similar. But as usual, you have to -2 if you want to get the usable host address. Again, I remind you, -2, one is for the network address. You cannot use network address to apply to host, and broadcast address, which is the last address within that subnet, which is a special address used for broadcast only. So again, you cannot use it for a host address. So -2. Okay. So if you improve this usable host address available, go to 2 power n -2. Okay. Include the -2 if you want to find usable host address. The one address that can be actually configured onto a host. Right? Okay, so from here you can see the rule is always this: in the subnet, yeah. Once you create subnet, it's the same as when you haven't created subnet. The first address range is always from the host side, all zeros. All right. So if you look at this from the binary point of view, okay, of course you can use the magic number to help you, and then you don't have to figure out this one. And the last host address within subnet is all ones on the host side. Okay, so that will be network address. All ones will be broadcast address. Right, and in between are your usable host address. Always the next one after, starting from the next one after network address, ending with the one prior to broadcast address. Right, so here is an example of creating 100 equal size subnets. As you can see, the process will be the same, but dealing with larger numbers only.
An enterprise network requires 100 equal size subnets, starting from 172.16.0.0/16. To subnet this network correctly, the first thing that I do is write out the subnet mask. There's my /16 subnet mask. I'm going to need to borrow bits from the host portion. If I borrow 1 bit, I have 2 subnets. 2 bits would be 4 subnets, 8 subnets, 16, 32, 64, 128.
I want to pause here. This is one way you can do it, right? Okay, because what you want to find out is the n and the n value. How many bits you borrow if I need 100. Okay, so basically you reverse the 2 power n. The reverse of the 2 power n, I'm not sure whether I mentioned to you before, but I think I did, is simply the log base 2 calculator. So this is the opposite of 2 power n. So if you put there, you need 100 because we're dealing with large number. So if you start to do with 1000, and then sometimes it's not right at the point where you're doubling. So if you're dealing with 100, maybe it's still doable testing one by one, right? But if you start to deal with larger number, 1000 subnets or 2000 subnets, like that, then you'll be doing a lot of calculation. So one quick way is doing log-based 2 calculator, where you just input the number of subnet you require. Since 100 might fall in between, so that's why you can see this 6 point something. So 6.6. So imagine if it's 7. So if I do the 2 power n calculation, right? Here you can see that is 100, right? And you get a 6.6 or round it to 7. So let's try 2 power 7. What does it give us? Oops, 2 power 7, yeah, 128. 128 can cover 100, right? So we round up to 7 because 2 power 6 is too small, 64. Okay, so because 100 falls between 64 and 128, then that's why we get 6 point something. So you round up, become 7. So 2 power 7, you get 28. All right. So let's continue this.
I'll need to create 128 subnets to meet the requirement of having 100 equal size subnets. So I've highlighted the borrowed bits in the subnet mask. We borrowed 7 bits. 2 to the 7th power is 128, creating 128 subnets. The last one in the subnet mask is in the 2's place. So I know that the networks will go up by 2. So I can go down here and fill in the networks. The first network will be 172.16.0.0/23, because we have 23 ones now in the subnet mask. And the next network will be 172.16.2.0/23. And we can see that if I list out the networks will continue to go up by 2. And if we go all the way up, I'll skip a few here. The last subnet will be 172.16.254.0/23. If I was to list out all of the subnets, I would have 128 subnets. For hosts in each subnet, we have 9 zeros in our subnet mask, and 2 to the 9th power is 512, So we'll have 512 minus 2, so 510 usable hosts per subnet. An easy way to figure out the hosts is 8 zeros is 256 hosts, and every 0 added on doubles the number of hosts, so 256 plus one more 0 would be 512 hosts, minus 2 for 510 usable.
All right. So if you notice this now, the magic number goes to the first subnet. First octet of the host part, right? All right. So as you can see here, just now we very quickly get onto it without recalculating, right? 2 power 7. 1 to 8, which is around rounding of that 6.6. Okay, that's another trick you can use if you want to find out very quickly. If you're given how many subnets and you don't want to do it too slow, and then, well, it's not too slow if you're very quick in doing this thing, but later when you're doing VLSM after this, where the number of hosts reach out to thousands, then using this technique, using log-based tool, will get you the number of bits very quickly, right? All right, so now we move on to class A. You start with class A, means you have a /@ prefix, right? So class A, you will start with the this part, the first octet, okay, and then you borrow from there. I think here they reduce the number of octets so that you can see. Oh, hang on, this is still, yeah, from here, sorry, I didn't notice these numbers. They just gave, because it's not relevant in binary, they just gave in decimal. So you start borrowing from here, 1, 2, 3, 4 octets, yes. And here you borrow 10 bits, 8 plus 2, 10 bits. So you borrow 10 bits. Okay, formula all the same, right? The technique all the same. Again, dealing with larger numbers. This one, even larger numbers you can create /@ network. And typically in the real world, the large telecommunication or service providers create networks based on this rather than the /24. You will see that /24 is usually small companies or home users will use, right? And then medium-sized companies will use /16, but really large organization like telecommunication or ISP, they will start to deal with /@ network, right? Because the requirements are larger. Okay, and you can see here the formula is still the same, right? So you can apply once you know the /24 basically, and then you deal with /16. You can apply the same technique for /8. Right, you just be careful because the values are larger. So, but if you use the same technique, you should not have any problems with it. All right. Subnetting across multiple octets here means that you go beyond. Let's say you start with /8, you go beyond the 8 bit just now. You go beyond, right? You go beyond the second octet. You go into the third octet. So these examples here show you that across multiple octets.
In classless subnetting, we've seen how we can borrow bits from the host portion of the subnet mask, and that the last one that's borrowed is the magic number, meaning that the last one, if we look at the place value of the 8-bit grouping, the last one in this case is in the 32's place. So the networks go up by 32. Starting with the 0 network, we have the 32 network, then the 64, 96, 128, so on and so forth, but the networks go up by 32. What about when we're subnetting from a Class A or Class B network address and subnetting generally in the other octets? Let's take a look at another example. This time we have a 10.0.0.0 network address and a classful Class A subnet mask, and we're going to subnet it. So we've taken the 8 bits and borrowed 3 bits, and now we have a /11 subnet mask. The last one in the subnet mask is still in the 32's place. If we look at this 8-bit grouping in this octet right here, the last one is still in the 32's place. So the networks will go up by 32. So the networks are the 10.0, 32, 64, 96, and they're going up by 32, but in the second octet. The only difference is now we have a lot more host addresses. We have 8, 16, 21 zeros for hosts, which means there's over 2 million hosts per subnet. For instance, if we take a look at this 10.192.0.0 subnet, the next subnet is 10.224. So that means that the host addresses go from 0.1 all the way up to 10.223.255.254 as the last usable host, and 255 is the broadcast. The next address is 10.224.0.0, which is the next subnet. All of these subnets are now /11. What about a more difficult scenario? In this scenario, we need to create over 300 equal-sized subnets of 20,000 hosts each, starting from the 10.0.0/8 network. So we need to create a lot more subnets, and we need a lot of hosts. Looking at this situation, we know that we're going to need to borrow bits from the host portion of our subnet mask. The question is, how many bits will we borrow? If we borrow 1 bit, we have 2 subnets. Now we have 4 subnets, 8 subnets, 16, 32, 64, 128, 256, 512. If we borrow 9 bits, we'll have 512 subnets that we create, and that will be sufficient to meet the demand for 300 equal-sized subnets. What about the requirement of 20,000 hosts each? We have 15 zeros left for hosts per subnet. 2 to the 15th power is 32,768. Minus 2 would be 32,766 hosts per subnet. That meets the requirement of having at least 20,000 hosts in each subnet. So this scenario would work. You can see here that I've now highlighted the borrowed bits from the subnet mask. I've also converted it to decimal here, 255.255.128.0. And I've already ascertained that the last one in the subnet mask is in the 128's place, so the magic number is 128. The subnets will still go up by 128, but they'll also need to go up for every number possible in the second octet. If we look below here, we can see our subnets. The first subnet will be the 10.0.0.0/17 subnet, then the 0.128 subnet, then the 1.0 subnet, then the 1.128 subnet. And as you can see, we're iterating through every possible number in the second octet and then going up by 128 in the third octet. If I was to list out every possible subnet, we'd go all the way up to 10.255.0.0, and the next subnet would be 10.255.128.0/17 is our last subnet, for a total of 512 subnets. In a situation like this, there's many more subnets and many more hosts per subnet, but the rule of the magic number still applies.
All right, so if you like to use the magic number, keep note that there's slight differences between how to use it in /24, /16, and /8. But if you look at it closely, it's just that because you go beyond the octet, right? So the first octet belonging to the host part will increment. Okay, increment based on the magic number on the second octet. Let's say for the /8, right? Okay, so basically that's it for subnetting. Okay, so we've looked at /8, /16, /24. Okay, subnetting. That means we start to borrow bits from different boundary. Okay, so far you've seen that yes, we can create subnets based on our requirement for the subnets, and usually, okay, we look at examples where the remaining number of bits for the host part allow us to have the number of hosts that also match our subnet requirement. So coincidentally, our subnet numbers match with our requirements, and then after we borrow the bits to create the subnets, the number of hosts per subnet also match our requirement. But there are cases where it's not necessarily so. Okay, that means our requirements, not only we want to meet the subnet part, but the number of hosts per subnet is such that sometimes it is beyond what the number of the hosts, but not only that, sometimes we don't need so much. For example, the previous example is how many thousand was it? 20,000, but you have 32,000. So 32,000 minus 20,000 is about 12,000 addresses supposed to be future use, but I'm not sure how that works really well in a real environment. Okay, so just 12,000, around about 12,000 hosts, address that's not being used because you require only 20,000 per subnet. But because of the way we subnet the remaining number of host bits, we have 32,000. So from now on, we're going to look at VLSN, which is an acronym for Variable Length Subnet Mask. So the title here is Subnet to meet requirements. Not to say that the previous one doesn't meet our requirements, but it meets a certain range of requirements. So if you have, there's another range of requirements where we want to fine-tune the solution to match further into our requirement. All right. So so we go through introductions first. Okay, from some theory. Right. So here we can see the topology diagram. Right. This configuration is very standard. Means it's very usual that you can. All right. So enterprise networks are meant to represent large organization network. But if you're a small organization and you can still adopt this, right? But sometimes it's overkill, right? If you're very small network requirements. But enterprise network mostly will have this kind of situation or configuration, right? So you can see that normally enterprise network has their own private network, and we already understood that it is only meant to be used by their own employees, their own people. We normally call it intranet. All right, so that means the public, which is part of the internet, okay, will not be allowed to access it for security reason. Right, so you can see here there's a private IP version 4 addresses being used for this network because it's private network and it's only accessible to your own employees, so it's called intranet. Okay, and then but we still allow communication with the public network, which is the internet. So we basically have a router that allows us to communicate if we want to communicate, two-way communication, right? Now, sometimes in your organization, even though you want to keep some of your network or most of your network private, which means public cannot access, right? But you also might want to share, especially if you have a website, right? You have a website or you have some services, okay, that you allow the public to view. So this is typical configuration, okay, where you create another network. Here is called DMZ. DMZ is a a phrase that is taken from military. This one is called demilitarized zone. Okay, so that means here you can provide some infrastructure or a network that still belongs to your organization, but you allow the public to access. Okay, you still try to protect this, but this private network, you don't allow any services at all. So maybe the internet will only reply to your own communication to the internet. Okay, but there's no services here that you allow the public to access. Here, you create another network that you allow services, maybe web server, maybe whatever service that you want public to access. Public will access, so public will have more access to this network, right? But you have separated, okay, these two network. This network will never have any information or data that you don't want the public to see, right? So even though you of course still protect, you don't really not protect, you still protect. So it's not that easy to attack, but because of the looser security, because you want to allow the public to access, then you expect that this might get attacked quite easily. But you are prepared. Okay, although this DMZ demilitarized zone, we call it, can be attacked, but there's really nothing of importance. The data, okay, the data there that you're worried about. So you still protect, but you also say that, okay, if there are some world-class hacker there able to go into this DMZ network, that's fine. We will just normally they will just overwrite, okay, overwrite this or take the backup, restore back the data or whatever, and they're not worried that any loss of data from this network is taken or what, because it's all the data here is also available to the public, right? So this is one way for organization to set up their network in such a way that they protect the really private data, okay? And then so because if you mix this together, then you have to be extra vigilant, because now public can access some resources here, and that could lead to if they can attacker can make use of any security vulnerabilities from one of this server to go to infect or to go into any of the other servers or workstation, right? In this way, because it's basically controlled by this router, so you don't you already block this part. They cannot access. They can access here, right? All right. So that's why the DMZ accompanies internet testing servers. Devices in a DMZ use public IP version 4 address. So no translation needed. Usually people serve web servers here, okay, or FTP servers. Okay, those that the public can access, right? So you have two networks. right? So maybe you one of the network you would use, both are so private, right? Sorry, this is private, this is public. Okay, you can use this as private, but typically you allow direct access to this because you're not worried. So public address is okay. Okay, so a company could use /16 network or /24 network boundary, right? And the DMZ devices or the servers will have to be configured with public IP addresses. So whether you choose 16 or 24 for this, it's up to you how big your network requirement is in this private network.
Can choose anything in between 16 or 24.
Yeah. That means you're talking about subnetting. Yeah, you can subnet.
Yeah.
Please notice that the subnetting is only happening in the private address space, right? Usually we don't. I'm not sure whether people actually do subnetting when it comes to public IPv4. They're simply so far I cannot see or foresee any use for it from my point of view. Because when you subnet, you're dividing the subnet, but then all the subnets are actually public IPv4 address. That means all you're creating, you're separating network, but then they're all public IPv4 address. So I don't see that you have a need to do that. You see, when you subnet, it's because you want to create networks, right? And usually your requirement is your own. What network you want to create. On the internet, where they use public IPv4 address space, who is this who is this organization that is dividing network on the internet, right? When as an ISP, right, when you're only able to create networks for your own use or for your customer use, and usually they have private network address, IP address, right? And even if the ISP give you a public IP address, right, that doesn't mean that not necessarily your router at your home is directly bypassing the ISP infrastructure, network infrastructure. That means you're not directly connecting to the internet backbone, right? So yeah, so that's why it's very seldom there is a reason I see that the internet itself is subnetted. Okay, but there's a lot of reason why private networks are subnetted. Okay. All right, so let's look at the subnetting based on host requirement, right? Let's look at the requirement. Okay, the number of when we look at so right now I want to start to say VLSM. When you look at VLSM, okay, when we're submitting based on host requirement first, right? So it's the opposite. For subnetting, we focus on the number of subnets we want to create, and then we look at the host, and then we just hope that the number of hosts is very close to it can support or very close to what you're requiring for the number of hosts per subnet. But for variable length subnet mask, this kind of subnetting is that first you want to see what is the number of hosts you require per network, and then you satisfy the number of subnets, right? Kebalik, yeah. So we focus on different parts. Okay. the previous one, the subnets, we don't because we don't look at the host part because when you create the subnets, all subnets have equal number of host addresses. Whereas for VSM, different subnet can be different number of host addresses. That's why it's variable length. That means each subnet may have different prefix. May have, because maybe in your required subnets, maybe 5 subnets, 2 subnets may require similar number of hosts, so they have the same prefix. Then the other 3 subnets you want to create may have different prefix because the requirement for each subnet is different number of hosts. Okay, recall that the different prefix number will actually control the number of hosts available, because the more you borrow bits, the more bits you borrow to create subnets, the fewer host bits available, right? So when you have different host requirement per subnet, you can control that. Okay, you can control the number of hosts by playing with the number of bits you borrow. So that means if I create, let's say I create 4 subnets. In this case, each subnet, it has a different prefix, which means each subnet will have different number of hosts. So it can match more closely per subnet the number of hosts needed. Contrast it with the previous subnetting we did. We care about the number of subnet, and that's it. Because all subnet will have all the same prefix, all the same number of hosts per subnet. Right? Right. So this is one scenario. Imagine now that you have a corporate network, and you're required to create 6 separate networks, 6 subnets now, right? But if you look at this properly, the operation sites, employees tend to be more. They tend to be more employees, okay? And then their network requirement in terms of number of computers which are hosts, of course, follows how many employees need to use those computers. So they have more. But as you go up the ladder in a corporate ladder, as you reach the top, the executive management, usually the number of employees reduce. You might have a very few executive management employees, right? Compared to the bottom, where you have all the operation and the employees in operation. So that means you tend to have that if you create a separate network or subnet for the executive management part, where the number of people there are few, that means the number of hosts or the number of computers you have in that network also very few. So that means the 2 network subnet requirements have different number of host requirement. Okay, this is what this is trying to show us as a scenario in the real world. Normally, typically, if you take a management or business course, they always show the pyramid. Okay, and they show you the hierarchy. Here operation, so depending on what your business is doing, so there are more people at the base of the pyramid, but at the top executive level there are fewer, indicated by it becomes a point there on this triangle, this pyramid. So that means fewer, if you want to talk in terms of number of hosts required for the network for each functional area of your business. Some functional area might require many hosts, and some functional area of your business require fewer hosts. And this is the requirement usually typically we actually have in the real world. Okay, if we use the previous technique using subnetting, yes, I can supply you 1, 2, 3, 4, 5, 6 subnets, but all subnets I've created will have the equal number of hosts. Okay, now remember that the IP version 4 status is that it's depleted. Okay, and the range is not that big. Even though you go to private, it's very limited. So we try to not waste address space. Wouldn't it be nice if now I can say, yes, I can create 6 subnets, but now I want to see for each subnet, I want to get as close as possible the number of hosts required for that particular subnet. And we do know how to do that by changing the prefix per subnet. Taking one of the original subnet, and then we further subnet it again. So VLSM is basically nested subnetting. You subnet, and then after that, pick one subnet that again. And if required, pick one subnet it again. Right? So this is if I'm allowed to take the phrase of software development programming, we have nested subnetting. Right? Previously we used one level subnets. VLSM means multi-level, so nesting the subnets. Subnet first, and then take one subnet, subnet again, right? And then so on. Right? So here's an example from previous. You can see that the engineering, maybe this is an engineering company, has 30 host requirement. And then we look at the other extreme, sells 40 host requirement per network, per subnet. And then we look at the top of the pyramid, we see the executive management, only 10 hosts required. Right? So, when you look at the example to do subnet here, you think about the multi-level subnetting. Think about that you do the subnet, and then you take one subnet, you subnet that subnet again. So it's nested subnetting, right? Just like when you are inside a function, you call that function again, so it's recursive, right? So let's have a look at this. Okay, so here, first thing I want you to notice is that we actually have different prefix. One is /22, one is /26, right? So we are actually subnetting again the subnetted content, or the original subnet that you created. Okay.
We can only subnet more, right? The number cannot be more than the original. It cannot be less.
The number of bits you borrow. Yeah, we're talking about the number of bits you borrow when you subnet a subnet. Of course, can be extended. That's how you extend it. Remember, once you subnet, when you subnet, perform the subnet, those subnetted let me just those subnets that you have already subnetted, you have already allocated, you cannot use anymore, right? So let me just so usually I think of subnetting like cutting a piece of cake so that you can divide the cake into pieces of cake that you can give to people. So traditionally, before this, when we subnet, we say we either cut it into two, right? I use a cake because the number of cake is still the same. It's just that when you cut two, that means you have two pieces of cake. Seems like more, two, but each piece of cake is smaller. So we can imagine that this cake represents the number of addresses. You still start with the original address. You subnet that. You have two equal, right? Then the traditional one, if you say, oh, I need 3, you just divide. Then you say, okay, this one go to that person, this one go to that person, this one go to that person. But what if I don't want them to have equal size? Because maybe the other person is a kid. The kid cannot eat so much. Okay, you don't want the kid to be hyper, so eat too much cake. So in that way, you divide. You have 2 adults, 2 kids. All right, you can say this: 2 adults, 2 kids. Yeah. So the adult, that means I need 3, right? I need 3. So traditionally, sorry, I need 4. So 2 adults, 2 kids. We always remember the number of the size of the cake is the same, okay? So the number of address is still the same. So you always start with the number, the address you're given, and then you subnet from there, right? So if let's say 2 adults, 2 kids, the traditional one, 2 adults, 2 kids also get the same amount of cake. But you said, can I give the 2 kids just like this? Let me get this different pen. Something like this. This they can only eat like this much each, right? So instead of cutting into 4, right? You know, two adults. Okay, so you still cut into 2 to 4. Now the adults still get their own. Okay. Now, of course, when you give this away, you don't have this anymore, right? This part you don't have anymore. You already given the 2 adults. Yeah. So the address from this range to this range, I think is 192. Already taken, right? So you start from here. This part of the cake, this subnet, you subnet it again. That's why I said subnet. You already subnetted, the first you get 4, and then the 2 you give to the 2 adults. But you take the 3rd portion, subnet it again, then these 2 go to the kids. So one kid, let's say kid 2, kid 1. So this range of address belongs to this kid. This range of address of a piece of cake, if you want, belongs to this kid. So now we have an entire range here, still free. Contrast this with this, all are taken up, right? And here the best thing is the kids each got a smaller portion, which actually what we want to give to the kids. So this is this is an analogy that I want to make about VSN. The typical subnetting will be like this, right? Where you cannot control. Yes, you can control that you have required 4 subnet, and you can give 4 subnet. But typically you use up all the address range because some of the address are wasted per subnet. But here we can get as close as possible to the number of hosts actually required per subnet. That allows us to have some saving of addresses that we can use for future. This one, for future use, I cannot do anymore. I have to redo my network, or I go a higher class. So let's say this one is /24, then I have to go. But here, I can still cater for further expansion. Maybe I use this part unused. Is that okay? This is the if you want to think about it, how the VSM actually works. So this is the subnetting. Here is the what is we talk about VSM. We subnet, then we pick one of the subnet, then we subnet that again. Okay, and there's no limitation saying okay, we can only pick one subnet to subnet again. We can, but always remember you cannot subnet that's already allocated. Like here, I already allocate my right, so this address I use up used by the sub. So I cannot touch this anymore. So I have to keep on going to the part of the range of address that's not used up yet. But maybe this one is this is a big kid, and here we got small kids. Even smaller kids require smaller kit. Maybe 4 here, 4 small kids. So one big kid can get this bigger piece, and then here we can subnet again into 4 pieces, smaller pieces. Okay, so you can pick one multiple subnet, more than one subnet, and each subnet you pick, you can subnet. Okay, to give you the purpose is very similar. Smaller kids maybe get smaller portion because they cannot eat so much. But in terms of networking, certain subnets may require smaller number of hosts because that is their requirement. So you want to match as close as possible their host requirement per subnet. Right? And this is the example we have now. So in this example, I got one, this example is the example where I have original, I don't really care, still subnetting, I give everyone 26/26. So whether required, we don't really look at this is the also 30, 23, 40, 35, 10, doesn't matter. Each of them, after I subnet, get equal number of hosts. We're not looking at the this is there will be some where the address will be wasted, right? So we look at the VSM. Okay, in this example, imagine if we use this very similar requirements, all have equal number of subnets given. But when you look at this, this is building A, building B, building C, building D. But then you link these 4 separate subnets together. Okay, but this, don't forget, this also, this also needs addresses. Where? Here, 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 here. So this, because this is wiring between buildings. So in between buildings, you don't need, you don't really, in the real world, you don't go and plug in any host in the wiring between buildings. But you know, router interface must have address. So each of these subnet, okay, only requires basically 2 host address with this and this. Of course, in addition to the network and broadcast, you only need 2 usable host address for each interface. Now, if you use traditional subnetting, not VSM, then all the networks here, including this in between will have equal number of hosts. So this part permanently you will waste those additional host address, and we don't want that. Okay, this is the thing that we don't want. We don't want to waste the number of the address range. Okay, to cover this, how many subnets do we have? 1, 2, 3, 4. Each building is one network. So remember, this is example. 4 plus the in between. Okay, 5, 6, 7. To cover 7 subnets, meaning we have to borrow 3 bits. 3 bits give us add subnets, right? Add subnets. One subnet for future use, but we have 7 subnets. Traditionally, we will allocate 7 subnets. That means each subnet will have, you borrow 3 bits, you have left, this is slash 24, 5 bits, so 2 power 5, 2 times 2, 4, 4 times 2, 8 times 2, 16, 32. 32 minus 2, 30. 30 number of hosts, yes, can cover 30, 30, 30, 30. But here, 30 minus 2, I'm wasting 28 addresses in between the building. Here, 30 minus 25, 5. 30 minus 20, 10. 30 minus 15, 15 hosts. 30 minus 28, 2. But here is worse. 28. 30 minus 2, I have 28 host address between the building, the land between the building wasted. You can see, right? So if you add up, you can see here the calculation to tell you how many addresses are unused. Unused here means then wasted now. Okay, especially this wide area network. This one between buildings, you link. You only need 2 host address actually, but because your traditional subnetting, you have 30 host address. 5 bits host part, 2 power 5 is 30. So each network subnet will have 30 addresses. So this here, you add up 28 times 3, 84. Total together 84 addresses wasted. Okay, so conclusion, traditional subnetting wastes addresses. Okay, so this is how we did for this one. Remember the cake? Even though there are three kids here, 1, 2, 3 kids, they still get the same equal portion as adults, and they get bloated stomach. They can actually eat so big, but then they eat because you get them. So we took up all equal number of hosts per subnet.
They always equal.
Yeah, they also equal traditional subnets. So that's why from traditional software we learn about varying the size of the number of hosts per subnet. That means the size of the subnet, if we say that the size of the subnet is represented by the number of hosts inside that subnet, so we can say the subnets we want to create using VLSN are different sizes. So that means you subnet, then you take one subnet, you subnet that subnet again, right? And then you have smaller pieces, smaller subnets. So you can then take the smaller subnets. Smaller subnets here means the number of hosts in that subnet is smaller. Then you take the smaller subnets, assign to those subnets that require smaller subnets. Okay, so this is VLSN. This is variable length subnet mask. What is the name VLSN? Because the subnet mask is the prefix. right? So here the prefix will be plus 3, 24 plus 3 is slash 27, right? Okay, slash 27. So maybe the other subnets you slash 27. But what about this? How do you make this smaller? That means you borrow more bits. You borrow more bits until, if you remember, there's a perfect prefix that match only 2, which is slash 30. Slash 30 means you have only two bits left in the host part. 2 times 2, 4 minus 2 equals 2. So 2 num fit. So slash 30 for that. So if you, for those the wide area network subnets, you get the slash 30. So you borrow, instead of borrow 3, for that, for one particular subnet, you borrow more bits from 3, borrow to 3 more becomes 24, 5, 6, 7 slash 30 lah. Right? So we do this way. We still need how many hosts? 1, 2, 3, 4, right? So we borrow 3 bits, give us 30. This because we want to cover the 30 for each, right? Even the smallest 15 before 30 is 32 is 16, right? 16 minus 2 is 14. 14 cannot cover 15. So the next one is 30. Okay, so 30 can cover this. Right, so we don't need to subnet further. The subnet we create traditionally can cater for this 4. But for this, we need to subnet. We pick one subnet, we subnet it again. So this is what happened here. Or after we subnet, we pick the first 4. Now, which one you pick is up to you. But usually we start from the starting subnet. Right? So we pick 4 subnet. Each subnet we allocate to the lanes. So LAN A, first subnet to LAN A, second subnet to LAN B, C, D. Then the rest are the remaining subnets. Sort of you allocate already 1, 2, 3, 4, ada lagi 4, 3. So you pick one. In this case, in this scenario, the network administrator pick the last subnet. You can pick that one, no problem. You can pick this one, no problem. You choose to pick this one. Okay? That means you pick the last subnet and say, okay, I want to use this subnet for the wide area network. This one, this part. I want to subnet that subnet further to create something like this. Right? So I take the last subnet and I want to subnet that last subnet. You can see subnet 7 will be subnetted further. So take that, come here. Okay? It's already this way, right? You already slash 27. But we further borrow. That means that the range, you just imagine, that means you can only use from this range up to this range. You subnet this part. Whereby this part, these other 3 subnets is free. Don't touch it. You touch only this part and subnet this part. Right? So you take that from that range, and then what you do, you borrow. Okay, remember the once you pick the subnet, we want to match the number of hosts here with the required one, and perfectly slash 30 match our requirement for number of hosts per subnet. So in order to get slash 30, we need to borrow 3 more bits, right? 24, 25, 26, 27, 28, 29, 30. Okay, 6 more bits will give us slash 30. And the remaining 2 bits, 2 power 2 minus 2 give us 2 usable host address, and it's perfect because the two host address just nice to cover for each subnet here, two interfaces, right? Okay, so if we borrow the 3 additional bits, how many subnets can you have? You don't count the 3 borrowed bits already. The original borrowed 3 bits. You have to start from where they are. Okay, so you don't touch that anymore, because that means if you kacau this part, the 3 bits, then you kacau this part. So you have to start from .244. So that means starting from here, you going this way. Oops, sorry. Okay, going this way. So the 3 bits you borrow don't touch, because then you kacau here. So even if we look at /30, because we start from .224, then we only need look at the 3 bits extra we borrow. 3 bits extra we borrow is 2 power 3. You get 8. That's how many subnets you can create out of the 224. If you borrow 3 bits out of the 224, you get 8 subnet. So that's why you get, okay, first subnet 0, 1, 2, 3, 4, 5, 6, 7. 8 subnets. Okay, now that you have 8 subnets within this original subnet, then you can pick, because how many we need? 3, right? 1, 2, 3. So we need 3. So we pick 3. The first 3 lah. Allocate to each subnet, go to the each wide area network. We have 3 wide area networks, so we pick 3. 1, 2, 3. So we still have, because we have 8, right? 8 minus 3, we still have 5 unused. In addition to the 3 subnets within this subnet, we have also 5 smaller subnets available. How cool is that? We actually try to match the number of hosts required. So basically, we have the 3 buildings that we can create, and we can still have also this one for the wide area network. So that means later on I can add another 3, the biggest subnets, right? Hopefully the same lah. So and then I can have further expansion later. Sorry, right? Because I still have the this one. I still have this free and this free. So you can see, compared to this one, I only have this left over. This all taken. So where's the saving I made? Saving I made is this part. This part I saved. I just took one and further subnet that is actually enough to give me 3 subnets for the wide area network. So now I have more ranges, more subnets and more addresses, including this part 3 that I can use further. So this is the power of PLSN. Any question on that?
No.
No, huh? If any question, please just interrupt and ask me. Okay, so
What if all the subnets are not available already, and then
then if really you can't work with /24, then you have to go to /16.
when company all the subnets full already, and then do they have to add? Do they have to add a new subnet?
Yeah, either you go /16. If like this cannot fit then you have to, that means you have to use another address. Even /24, you have to use another address. Hopefully you have available another address. Remember, all these subnets here that we create is based on the original, just one network address. One /24 network address, which is which is actually given here, this one. This is our original network address, /24. So if this not enough, hopefully you have another one, 192.168.21 or dot something lah here. Then you can subnet from there also. But another way is, instead of starting with /24, you start with a /16 network address. Then definitely you will have enough. If that's not enough, either you use in the same class again, an additional network address in the same class, or you can go all the way to class A to start off your subnetting. All right, so you've got a lot of options depending on your situation. Does that answer your question?
Yeah.
Okay, right. So let's relax a bit and watch this video.
The basics of VLSM, or variable length subnet masks, works like this. 1. Subnets do not have to be equal sizes, as long as their address ranges do not overlap. So we can create unequal sized subnets. They do not all have to be the same size. 2. When creating subnets, it is easier to work from larger to smaller subnets. So for example, I have the 192.168.1.0/24 network. I subnet the network into 4 subnets /26 subnet masks. So the subnets go up by 64. I now have 4 equal-sized subnets. With VLSM, or variable length subnet masks, I can decide that I want to change one of these subnets and further subdivide them into smaller subnets, as long as the address spaces that I create, or the subnets that I create, do not intrude into the other subnets. For instance, I could take this 192.168.1.192 subnet. The address range for this subnet goes from 192 all the way up to 255. What I can do is I can say, instead of having this subnet /26, what if I take that address space and divide it into 2 smaller subnets, size /27 each? If I do this, I effectively have created 5 subnets. The 3 subnets up here are 64 hosts each, and the 2 new subnets that I created from the 4th subnet are 32 hosts each. The reason I can do this is because my 2 smaller subnets do not intrude into the larger subnets. This is variable length subnet masks. In this situation, it has also allowed me to create 5 subnets, thus escaping the equal-sized subnet limitation of creating subnets in powers of 2. This gives me greater flexibility and allows me to create subnets of different sizes based on the requirements of my network.
Right, so that was a summary of what we have discussed. Right. Okay, so here in this slide is, you can actually, when you use a subnet, right, you can implement the subnet based on, for IPv4, based on the subnet mask. Remember, when you subnet a subnet, because it's a prefix different, this now was 27 and this /30. So that means when you get the subnet mask for /30, it will be 252 at the back. Okay, you just convert to binary, and you can see the last you just put all ones in the network part, all zeros in the host part. You get a pattern of bits that will translate to binary as 255, 255, 255, 252. Similarly, if you do that to /27, you'll get at the last octet 224. So that means when you change the prefix, you'll get a different subnet mask. And when you do the configuration for the interface, let's say for /30 in this network, this is the interface on router 3, this is the interface on router 4. So when you configure that, then when you configure the address that you select from the range of address that you have, you also will put in the subnet mask right at the back, right? So that subnet mask will work with the IP address. Okay. Now, if you make a mistake here, the subnet mask doesn't match with this IP address, your network will have problems. Okay, because a conflict with the subnet mask and the IP address. Okay, so typically what you do, okay, in real or in SBA is you perform your VSM. Then from your subnet mask that you created, whether it's the /27, let's say in this example, and so we have /27, /30, you pick from here, you pick from the range. You decide in the real world. You decide yourself which one you pick to give to the LANs that need the addressing scheme. But in the exam, normally the question will tell you assign the first subnet to LAN A, assign the second subnet to LAN B, and then when you do subnetting, assign which subnet to which, right? For exam question or SBA question, the skill-based assessment question, the question will tell you which subnet to use. Okay, but in the real world, because you are the one designing and nobody telling you anything, so you have to decide. All right. Okay, you decide which one you want to assign. Right. So once you assign, okay, in your documentation you assign already a table. You assign already. Then it's time to configure. So this is the configuration wise, it's still the same. The only difference is the subnet mask. It used to be when you are doing normal configuration, the IP address given to you, you just put, because it's not subnetted, right? You just put 255.255.255.0 for /24, right? But because you're doing subnetting already, and furthermore you're doing VRSM, you'll find that for each subnet you created, okay, you'll find that the subnet mask follows your prefix, how many bits you borrow. So if you subnet a subnet, you borrow more bits, okay, then the subnet mask will follow also that prefix. So /30 thereby 252 for subnet mask. Okay. So in the command, it's still the same. You go to config terminal. You want to say you want to configure which interface. You type the interface. You go to config interface area. Then you type the same command. The only thing different now is that the address you pick for the addressing scheme and the subnet must follow the address belong to which subnet, and the subnet is what prefix. So you have the subnet mask effect there. Okay. Any question here?
No.
Okay. No, so I will give you a preview of your SBA. Okay, you have one more apart from your assignment. You already done your midterm test. Okay, so the other two part of your component of your coursework are the assignment and the SBA. SBA stands for skills-based assessment, and the assessment is based on you given a packet tracer activity. But in addition to the packet tracer, you have to use your skills in doing the subnetting and VLSN, right? Because you're asked to subnet, you're given a scenario, you're given a scenario of network requirement. Based on the network requirement, you have to do subnetting or VLSN. And once you produce the subnets based on the instruction from the question, you will do the addressing scheme. That means previously in your packet tracer activity, you're always given that table on top listing all the addresses, right? So now you have to generate that. You have to create your own based on the instructions given. Once you already allocate your addressing scheme, you know already which host should get what address, which LAN should get which subnet. And then the next job you have to do is then go into each of the hosts, go into each of the routers, okay, and implement your addressing scheme. Meaning assign the IP address, right? All right, and basically that's your SDA. Okay, right. So you can see that from the beginning of the practical session, you learn about how to use packet tracer. Then you learn about what are the network representation within the packet tracer, and you learn about how to assign IP address, how to troubleshoot, how all this, right? Now you learn about VLSN. Okay, so once if you know already, if you pass your SBA, you are able to go outside. People say, okay, this is my network requirement. You are now in a position to, if need be, create your own addressing scheme to cater for their network requirement, and then apply all the addresses based on the addressing scheme to their hosts and their intermediate devices. Okay, so basically you can create, you are able to create a network, okay, and configure the network. All right, so here this slide give you the last piece of the puzzle on a router. How do you implement? So the command is the same, right? The command is the same. All you learn in the subnetting and VLSN is how to create the addressing scheme, how to create the subnet. Okay, and then assign which subnet to which LAN based on the requirement. And within each LAN, you have the range of usable host address. Okay, how to pick which one assign. Okay, so in the question, which one to assign will be given to you. They say, oh, use the first usable host address to assign to PCA or something like that. In the real world, you have to decide your own, right? Okay. Right. Okay, this was the assignment already. Assignment. You can see that building A, B, C, D, and then the last we chose the last subnet to subnet again to create /30 subnets for each of the subnets within that subnet, and then we just pick the first 3 subnet, and then the assign each wide area network subnet with the subnet addressing scheme, right? So you can see once you have the you know it's a 224 is the network address, okay, and then you know that it's going to be, if the next one is 228, you know the broadcast for the first subnet will be one below the 228. So that means 224 here is the network address. Broadcast address will be 227, right? So the 2 left hosts, usable hosts will be 225, one after 224, and then after 225, 226. After 226 is 227, which is the broadcast address, and then the next network address. So the next subnet. /30 will give you only 2 usable. 4 host address, 2 usable. Alright? Can you see that? So that means you can assign between router 1 and 2, the interface that's connecting the R1 and R2, R1 side, the interface will be 225. R2 will be 226. All right, and this network between R1 and R2, router 1 and router 2, is the 222.224 network. You see that? Again, for the building, because you select the first subnet for the building A and so on, A, B, C, D, you can also see the network address. So if building B network address is 32, that means the previous address is the broadcast address for building A, which is .33. Sorry, the .31. Okay, so that means the range of usable host is between .1 to .30. Any questions? Yeah.
So different subnet must have different prefix.
Yeah. Remember, all these actually are /27 when you first do the subnet. Yeah. Then you said, I want to take the last unused range of address. This 8, subnet number 8 here, and I want to subnet it again to provide subnet address for each wide area network here. Okay, so I wanted to subnet again because I want to match the number of hosts available as close as possible to the number of hosts required by that subnet. So within this range, starting from 224 until 255, 254, I think it's 255, yeah, 255, right? Then I divide again. Because I /30, then I divide into 8. Then the first subnet range I give to R1, R2 subnet. And then the next range, the second subnet I give to R2, R3. So of course, then when we are looking at R1, R2 subnet, it's a /30 network. But when we look at building A, because it's not subnetted, right? It's still on /27 network. The key to see here that no overlap. There's no overlap. What? We don't overlap the. Even with subnet here, this subnet is actually free here. Then we subdivide it into 8. Okay, we don't overlap any of the other subnets. Yes, when you subnet a subnet, the subnet would have different prefix number. All right. Okay. Yeah, let's look at this video.
In this scenario, the task is to subnet the 172.16.0.0/23 network.
So, in this example, you can see the requirement of the subnets. Each subnet required number of available hosts is different, right? So we try to find we try to subnet first. Okay, normally what we do is we sort our required subnets based on the number of hosts they required. Okay, how to sort it? By descending from the largest number of hosts required. Okay, so we sort our subnets requirement based on number of hosts, descending mode. All right, and then we divide first, and then once we allocate to the first, or no, how many of the subnets that can fit, and then for those subnets requiring smaller number of hosts, then we subnet again. We take one available subnet, we subnet again, and so on. You can see here, this example will show you
this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets. One network for 200 hosts, one network for 100 hosts.
Sorry. I also want to mention this is a slash, starting from /16.172 is class B. So starting from /16, yeah, /16 network. Okay.
In this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets. One network for 200 hosts, one network for 100 hosts, one network for 50 hosts, one network for 25 hosts, one network for 10 hosts, and 4 point-to-point networks for 2 hosts each. Before I begin to create these subnets, I need to check to see if I even have enough addresses in this address space to create all of these subnets. So by writing out the network and the subnet mask in binary, we see that we have a /23 subnet mask. Here's 23 ones in binary. The last bit is in the 2's place. If we look at this 8-bit grouping in the 3rd octet, we see that the last one is in the 2's place. That means the subnets would go up by 2. So the next subnet will be 172.16.2.0/23. So the address space that we're working with goes from 172.16.0.0 all the way up to 1.255. Let's see if this is enough addresses to create all of these subnets for this specified amount of hosts. I can see that starting from a /23 subnet mask, we have 9 host bits. So effectively there's 512 hosts. If we look at each one of these subnets that we're going to need to create, I cannot create a 200 host subnet, but I can create a subnet for 256 hosts. That number does not reflect the usable hosts, but the total number of addresses in the subnet. Similarly, I'm unable to create exactly a 100 host subnet, but I can create a 128 host subnet, a 64 subnet, a 32 subnet. 4 host subnets will satisfy these requirements. If I add up all of these numbers, 256, 128, 64, 32, 16, and 4 subnets of 4, the total number is 512. So I'll have exactly enough host addresses to create these sized subnets and meet the requirements. Once again, these numbers here for the subnet sizes that we'll create do not reflect the usable host addresses, but the total number of addresses in the host portion of the subnet ranges, including the network address and the broadcast address. So let's get started subnetting this network using VLSM, variable length subnet masks, and working from largest subnets to smallest subnets in order to create all of the subnets required. So working from largest to smallest, the first thing I need to do is to create a network for 256 hosts to satisfy the 200 host requirement. What I can do is I can subdivide this single network of 512 hosts into 2 smaller subnets of 256 hosts each. So instead of having a 172.16.0.0 network /23, I change the subnet mask to /24. This creates 2 networks, 0.0 and 1.0, each subnet having 256 or 8 host bits. Notice how the subnet mask has changed from /23 to /24, and I now have 2 256 host subnets. What I can now do is keep the first of these subnets and subdivide the second. To do this, I simply take this 172.16.1.0/24 subnet and change it from /24 to /25. So now I have the 172.16.1.0/25 subnet. This creates another subnet, 172.16.1.128. Both subnets have a magic number of 128, meaning the networks go up by 128. So I've taken this one network of 256 hosts and subdivided it into two networks of 128 hosts each. Now I have a subnet to meet this second requirement. Moving on from there, I'll keep the first of these subnets and then further subdivide the second one. So now we no longer have the 1.0 network in its place. We have the 1.0 subnet and the 1.128 subnet. Then I subdivide the 128 subnet into two smaller subnets /26 each. So now there's no longer a 128 subnet. There's two subnets in its place, a 128 subnet and a 192 subnet. Both of these subnets have a /26 subnet mask. If I was to write this subnet mask in the binary conversion table here, we would see that in the fourth octet, /26 means that the last one in the subnet mask is in the 64's place, and the networks go up by 64. Furthermore, with the /26 subnet mask, you only have 1, 2, 3, 4, 5, 6 host bits, and 2 to the 6th power is 64, meaning there's 64 hosts, 62 usable per subnet. I now have my 256 host subnet, I have my 128 host subnet, and my 64 host subnet. I can subdivide the second of these two subnets into two smaller subnets of 32 hosts each. To do this, I take the 192 subnet and subdivide it by changing the subnet mask from /26 to /27, creating two subnets of 32 hosts each. So now I'm no longer using the 192 subnet /26, I'm using it as a 192/27 subnet and a 224/27 subnet. From here, I still need a subnet for 10 hosts. I can take the second of these two subnets for 32 hosts and subdivide them to two 16-host subnets. To do this, we take the 224/27 subnet, change the subnet mask from /27 to /28, and now I have two smaller subnets. From here, I take the second of these two 16-host subnets. I only need one. The second one I'll use for 4 subnets of 4 hosts each. So now instead of the 240/28 subnet, I have the 240/30, the 244/30, the 248/30, and the 252/30 subnets. Looking at the subnets that have been left, we have the 172.16.0.0/24 subnet. This is good for 256 hosts. We have the 172.16.1.0/25 subnet. This is good for 128 hosts. The 172.16.1.128 subnet /26 is good for 64 hosts. And the 192/27 subnet is good for 32 hosts. The 224/28 is a 16-host subnet. And then the last 4 subnets /30 each, 240, 244, 248, and 252, are good for 4 hosts each. Once again, these sizes do not reflect the usable hosts in each subnet, but the total number of addresses in the host portion. For usable host addresses, you need to -2 from each subnet. If we examine the host addresses closely, we'll see that none of the subnets overlap. In other words, this 172.16.0 subnet goes from 0 all the way up, since it's /24, to 255. You can see that the next subnet starts at 172.16.1.0. so the two subnets do not overlap. Similarly, this second subnet goes from 0 to 127. And we can see that from host 0 to 127, the next subnet at 172.16.1.128/26, that there's no overlap. This subnet ends at 127, the next subnet begins at 128, and so on and so forth. In the end, we've created 9 subnets of different sizes: a 256, a 128, a 64, a 32, a 16, and 4 host subnets. This is VLSN, and it allows us to create subnets or networks specific to the needs of the network.
All right. So the example given just now was created specifically to show you, based on they create the examples or the scenario where you can exactly fit everything, and each subnet required is just the next subnet. So you subnet and subnet and subnet and subnet, right? So there might be a situation like that, but this one was created especially to show you that you can subnet and subnet and subnet and subnet and subnet. But as long as addresses range you create or subnet you create does not overlap the previous range of subnet. Okay, so basically each subnet becomes smaller and smaller and smaller. Okay, that is why you arrange the requirement in descending mode based on the sorting of the number of required hosts. Okay, so later when you're doing your VLSN example, this is exactly what you need to do. Okay, the scenario may not sort it out for you, but you have to list it out and sort it based on the number of hosts required per subnet, and you work based on that. You have to allocate starting with the largest required number of hosts. Okay, obviously, in the exam they will not give you. In the real world, you may need to check: is it enough? Like what the guy said, is it enough or not? First, then you proceed. But I've never seen any question that where it's not enough, so you have to choose another address range, or starting with another prefix. So for the test or exam, the exam on SBA, you don't have to really check that much. But in the real world, you might need to check. Okay, because the address you're given may not able to cover the number of hosts in total. That's what the first checking was about. But again, this is an idealized example because if you wanted to show you can subnet, yeah. All right. 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 So addressing scheme, network address planning. Okay, planning IP address assignment. Well, that means you have subnetted, right? So it's only one part of your network configuration. As I already mentioned before, the requirements will come to you, right? So if you're I'm going to talk about requirements in terms of industry. If you go outside, the person, whoever is assigning you to do this work, will basically first of all, they might not even know how to divide the LAN, how to subnet the LAN. I mean, in terms of what, functional or whatever. You might be in a position where you have to investigate their business, their business environment, to find the best way of how it's best to divide the network. Okay? Or they might already know, okay, I want to divide based on functional areas of my business. Or, for example, here the example is how you best divide to create networks in a college. So you might think, okay, they might not know because they might not know anything about computing or networking, right? So you look at, you first of all ask them, what do you want to use the network for? Or they say, I want to provide network for my student, for my faculty, for my admin. Okay, but the thing is, my students, I don't want them to access from conversation like that. You take note, then you notice that, oh, based on functional is the best way to first of all create division in the network of subnets for the network, right? So these are the things that you have to figure out how to plan to divide the network. Once you start to do that, then you might be given a whole range of IP domain. You don't even have to do subnetting, right? Remember, each unsubnetted, if it's /24, give you 254 usable host address. But then they might say, oh, you can use .0, .1, .2. So then maybe you don't even have to do subnetting. And you look at the college, growth may not even need to do for many years ahead. So maybe your job may be easier. But what if they already said, okay, but we are only given this address? Then you start to think about you based on one address, how can you create this network? Then you're doing subnetting already. And if they start to say, not only we want to have these are the number of computers we want for each network, then you start to look at the number of hosts required. Okay, so the best practice is you want to save network address, right? So you might then start thinking about VLSN, right? So it says here that the decision on the each subnet in terms of size, the number of hosts per subnet, and how host address will be assigned. The how host addresses will be assigned, there's no hard and fast rule. That means there's only best guidelines or best practices. Like I said earlier on, you get a range of address, and you look at the host. What kind of host do you have? Okay, to make it easy, you differentiate between hosts that provide service and hosts that utilize service. So hosts that provide service like servers, printers, you might want to give IP address within a certain range. Okay, this is for ease of maintenance. Okay, maintenance. Because you know, okay, for server, that means it must be this range. Gateway address, the address on the interface of your router that leads to the network. Again, based on convention, but standardize it for yourself. Pick a range that for these important network services, and then the other range you give to the host. This is how host addresses will be assigned. Okay. Right. Planning to address the network. Why you want to be very particular, very systematic about assigning IP address is because you want to prevent duplication of addresses. If you don't document, you don't really care, you just randomly say, okay, once you have a range of addresses, you say, I give this one, simply like that, without any systematic way to provide the IP address. Later on, when you do need to scale up the network, or you do need to, add a few computers or whatever, you make yourself be in a position where you might have duplicates of duplication of address, simply because it's very hard to keep track of. Okay, if you randomly assign, you don't have a systematic way to say, okay, this range is for this range is for this, right? This is after you do subnetting, yeah. After you get the range of addresses, okay, then you want to assign, right? This one, there's no hard and fast rule. I mean, you are only based on best practices. How other network administrators in what kind of situation assign the address? You'll find a way that is easier for you for maintenance later on, for scalability, right? Okay. Monitor security and performance. Basically, if you provide a range saying that this range already, later when you want to secure the network in terms of monitoring traffic, maybe from the management already said to you, I want to monitor traffic. So monitoring traffic, usually you have a firewall. Then you can specify what range to monitor. So if you have done systematic assignment of your IP address is very easy for you. Okay, you don't have to list individual IP address. You can say that, oh, within this range are the students from lab A. So I want to specifically monitor lab A. So I just place this range of address into the whatever firewall or whatever packet filtering server you have, right? So again, it's all depend on your what you want to do. So here is monitor security and performance. You might want to trace from certain networks. You want to see, because high traffic from there, you want to identify which IP address or things like that. Provide control and access. Again, you want to block certain addresses, right, from accessing certain resource. It's easier if you already assign systematically within a range. Working with range is easier compared to listing out different address, because you randomly assign address. Okay, so you need proper planning and documentation. Everything must be documented, not only for the sanity of the next person who's going to look after the network or to scale up the network. Must provide control access to servers from internal hosts and external hosts. Easier for you if you, again, back to my original statements, easier for you to monitor, control, because you monitor and control based on IP address. If you haphazardly or randomly assign, it's very, very difficult for you to now implement structure on it. Okay, layer 3 static address assigned to a server. Static address means you fix. You don't use DHCP. You fix, right? Because hosts that provide services, once you assign it, you should make it as permanent as possible. Because then you need to go to each host that is a client that can access that service, like a printer, for example. And you don't want to keep changing, setting up. Once you set up, then if nobody change the IP address, then it will remain so. Okay, then every time you say the person want to add a printer, add printer into their so they can print to the network printer, then you can provide just, okay, use this IP address, the printer IP address. Okay, because it's fixed. Right? Monitoring security and performance, of course, means network traffic examine. Right? Examine means you're filtering, right? Again, the one I mentioned. If you, it's easier to filter a range of address rather than you have to input one address after another, because it's just jump between addresses, a whole range of address, right? Right. Devices that require address include end user clients, servers, intermediate devices like now routers interface, and the specific router interface that's used to access outside network, which is the gateway. Right. The remote management is basically that switch VLAN 1. Remember, we learned about this in the packet tracer. Switch VLAN 1, where you also have to assign IP address, so you can remotely manage the switch. Okay, right. So end user client can be set for DHCP to save time and manual errors. For my own personal view, if it's connected using wired networks, then it makes sense to statically assign it, because it's permanent. Like in the labs, all the computers are permanently there, so there's no real need to dynamically assign. So usually, if it's permanent computer, you assign the IP address permanently. That means you manually. But the company might also want one of the network that you design, is one of the subnet, is actually a wireless network. So wireless network, definitely you want to be dynamic, because people can jump in and out of the range of the IP, the wireless network, and they once they're within range, they want to connect and use the network. So for that you use the dynamic host configuration protocol to assign the addresses automatically. So that means Sometimes within one subnet, one range of the address you allocate for wireless, one range is for wired, means fixed. Okay, you have to decide also. Right? So a change in the subnetting scheme requires reconfiguration of everything changes now if you subnet, right? The prefix change, the subnet mask change, things like this. So that means you have to reconfigure your DHCP server, right? And recall that for IP version 6, they use combination. They can either use each or combination of DHCP version 6 and Slack. Remember, Slack runs within the router. Okay. Servers, definitely you should configure static because they provide service. Right? Intermediate devices, also because for remote management, you don't want to keep guessing if it's dynamic. You can't even guess, because within a range you have to guess. So don't guess. For remote management of switch, you put static address. Okay. Router interface for gateway also put as fixed. Right? So this example in the box there, you can see host devices. You give a range from .12 to .229, that range. Servers, another range, .230 to .239. Printers, 240 to 249. So that means you reserve for printers 240 to 249 means you reserve about at least 10 addresses. Okay, 10 addresses allowing you to potentially have 10 printers. Right, so you start to assign from 240, 241, 242. As each additional printer you add into the network, then you assign the available within that range. And then easier to remember, easier to document, easier to configure to maintain, right? And then gateway, maybe you say 254. Now, this is not, again, I want to emphasize that this is not hard and fast rule. This is not the only rule, but this is a good rule. So you won't get wrong depending on your network requirements, whether you have servers or printers, right? Okay, but this is a good, you can see that it's a good rule, right? The worst thing you can do is randomly assign. Mini, mo, I assign this address to that. I assign this address to that. This is systematic, you can see, right? Okay, design configuration for IP version 6. Right, so we reached 1140 already. So I don't want to overload you guys, even though it's just a few more slides, probably just a few more slides, but I want to stop here. I think it's a good time to stop, right? So before we move on to the next session, which is the tutorial, we go for a quick break, 10 minutes. Is that okay?
Okay.
Okay.
Yeah. Okay. Right. So 10 minutes. So I'm going to stop recording now. So around 11:50 we come back and do our tutorial, yeah? Guys, can we disconnect this one, connect with the tutorial session meet? Okay? See you in the tutorial session meet.
Okay.
Okay.
Hello. Hi, welcome back.
Hello.
All right, so I'm going to look at tutorial 7 last week. There's some questions not okay, answered already. Yeah, there are 2 questions at the back, 3 questions at the back, 4 questions at the back. Answered. Okay, so those questions not answered, please fill in the answer. Trevor and Kelvin.
Okay.
Okay, right? And no, okay, no is the answer. Okay, I will mark it. For this week, right? So we start to do on tutorial 8.1, subnetting IP networks. Okay, so here we are doing the subnetting, yeah, in this set of questions, subnetting. The 8.2 tutorial we'll do after that lah. Actually, the 8.2 and 8.3 are VRSM. Okay, class A and class B and class C. Class C first, and then class. So this session we just do tutorial 8.1 first, which is subnetting. VRSM we do later. Okay. So the tutorial 8.1, question 1, you're given IP address class C, 192.168.3.0/24. The school consists of 20 classrooms and 5 offices. So each classroom and office needs a subnet. So that means how many subnets will you need based on the requirement. Okay. And then part 2, how many bits must be borrowed to support the required number of subnets. Number 3, once you determine number 2, how many usable host address you need per subnet. Okay, and then you already subnetted, what is the value of the new subnet mask, since you have the prefix already. Okay, and then part 5, provide the first 4 subnets. Okay, first 4 subnets. Normally gives out the subnet number. Normally we start subnet number with 0, and then subnet address and prefix length, first usable address, last usable address. Usually you try to give the subnet address with the prefix length and then broadcast address, then you can easily find the first and last usable address. Okay, right, so in question number 2, basically very similar question to question 1. Question 3, the requirement is given to you in terms of the network diagram. Okay, same question, different is the way the requirement is given to you. All right, question 3, basically the question is given to you in terms of topology diagram. Determine how many subnets from that network diagram, how many bits borrowed to provide that required number of subnets, how many usable host address per subnet is required, is provided, and then compute the new subnet mask, and then finally to list off the subnets within that table. All right, that's 8.1, yeah. All right, for question 1, part I, para, we have 20 classroom and 5 offices. So if you need to provide a subnet for each classroom and each office, so how many altogether? How many subnets altogether needed? Look at the requirement. How many subnets you think you need when you need to provide for 20 classroom and 5 office? So you need
Um,
a sub for each classroom, a subnet for each offices. So altogether, how many subnets?
shouldn't it be 25?
Yeah, 25, correct.
Oh, okay.
So Noel, if 25 subnets are needed, then how many bits should you borrow that can provide you 25 subnets or accommodate 25 subnets? How many bits you need to borrow?
One.
One bit gives you two subnets. 2 power n, 2 power 1 is 2. So if you need 25 subnets, how many bits would you need? Formula for how many bits is the opposite, right? Log base 2. Okay. If you put 25 there and you press calculate, how many bits do you see? I'll give you the link for the subnet calculator. What did you get? Manuel, what did you get if you put 25 there? Log base 2, 25, calculate. What did you get?
4.64.
So if you round up to integer only,
5.
so 5. So you need to borrow 5 bits. And then Kelvin, if borrow 5 bits, okay, borrow 5 bits from add bits because class C, right? Add bits of Kelvin. So if you borrow 5 bits, how many bits remaining? Kelvin? How many bits remaining if you borrow 5 bits? So Noel, your answer is 5, yeah? 5 bits.
19?
No, because it's class C, so you only have in the host part 8 bits, Kelvin. So if you borrow 5 bits already, remain how many bits?
3.
So 3, yeah. What's the formula to get usable host addresses? 2 power n minus 2, right? So if your n is 3 bits, how many usable hosts do you get? Yes, 6 usable hosts for Kelvin. Noel, your answer will be 5 bits, right?
Yeah.
So Kelvin, you will write 6 usable hosts. Right. So Noel answer 5 bits, yeah. Okay, so compute the new decimal value, Farah. So if you borrow 5 bits, what's the prefix now? From /24 becomes slash borrow 5 bits. So /24 plus 5 bits becomes slash
borrow 5 bits become
24. Originally 24. Now you borrow 5 bits. It becomes slash what?
19.
The 24 plus 1, 25 plus, if you plus 5 bits, it becomes slash
4, 5, 6, 7, 8, 9, 29.
Oh, 29.
Yeah, slash 29. So that means 29 is the network part,
Oh, okay.
right? So network for subnet mask, all the network part is 1. So you will write
5, 5, 2, 5,
in
5.
binary, in binary. So the original will be like this. Okay, I will type Karen.
Okay. Okay.
1 1 1 1 1 1 1 1. That's the first octet. 1 1 1 1 1 1 1 1. That's the second octet. 1 1 1 1 1 1 1 1. Third octet. So that's clear. The slash 24 is this, right? Slash 24 is this because the 24 bits in the network part and 8 bits in the host part. So now you are borrowing 1, 2, 3, 4, 5, 6, 5 bits only. 5 bits from the host part, right? Because your side is 5 bits, you borrow 5 bits to get 25 subnets needed. So if you borrow 5 bits from the network, from the host part, now the 5 bits become the host part. Subnet mask is all the network part once. So you then convert all the zeros that you borrow to 1. So you borrow 5 bits. 1, 2, 3. Oops, sorry. 1, 2, 3, 4, 5. Right? So this is the binary subnet mask. Can you convert this to decimal?
To get the link.
Okay, so the first part, all x is 1 means convert it into decimal.
How to
convert?
yeah.
Okay, the easiest way, if you don't remember the computer organization way, is to use calculator.
Okay.
Right? Go to programmer. Then simply type the number of binary, which is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So what's the decimal?
Oh.
Yeah. So decimal is 255. So you write 255. So you write 255 dot. So the next octet also at bit all ones. So it's the same value. So dot 255 again.
Type 255 again.
Yeah, because the next octet is also all ones at once, right? Okay, the third octet.
Oh, it's 255 again.
Okay, yes. Okay, now the last octet, because now you borrow 5 bits. The last octet have 5 bits 1 and 3 bits 0. So use the calculator. What's the value? What's the decimal value for that? 111 11 000.
248.
Yes, correct.
Oh, okay.
So that will be the next, the new subnet mask. It's different from the original one. The original one is 255.0. But since you borrow 5 bits, right? So the 5 bits you borrow belong now to the network. So now the 0 becomes 248, right? Okay, huh?
Okay.
All right.
One,
Okay,
two,
so
three.
yes, you're doing fine so far. No, can you put for the subnet number? You don't put the dot in front.
Oh,
Yeah, and please write the full subnet address in decimal.
yes.
The first, the second, the third, and the fourth. So no, subnet number of course is 0, but it's not dot 0. Just now you put 0. Subnet number is just the number, the subnet, yeah, so 0, and then the next one is 1, and then 2, and then 3. Right? And you need to put, the easiest way for you to do is come up with the subnet address first. What's the subnet address? Remember the magic number? No, that is the subnet mask. You put 255 subnet mask. What is the original address? 192.168.3.0.
Oh,
Right. So that's the first subnet address. The next one, what is the magic number? Look at the Ferris binary. The last borrowed bits, where is it?
the
What is the value, position value for the last bit? That one.
2 power 3.
1, 2, 4, 1, 2, 4, 8, right?
Yeah.
So that means keep adding 8, isn't it?
Yeah.
No, sorry. You, is it 8? 1, 2, 4, 8. Yeah, it's 8. And then so on. You do, right? Just continue. This one is 16. Next one is yes. Now you remember we only take the first 4 subnets. Of course, there will be other subnets because 2 power 5. Remember, we borrow 5 bits. 2 power 5 tells us how many subnets we create, but we only list out the first 4 because the question say list the first 4. So now that you get the subnet address, what is the broadcast address? No, do the broadcast address first. This is the step to do. 192.
Do we include the prefix?
No. Only the subnet address actually got prefix. So you go to the broadcast address, and what's the broadcast address? 192. .3.7, correct. So now, very easy for you to put the first usable address is the next address after the subnet address. .3.1. Then the last usable, also easy, just one below broadcast address. Yes. So right. Now you can do the other broadcast address first. Because once you do the broadcast address, you can do the first usable and last usable very easy. Is that? Exactly. Yeah. Do the broadcast first. This ensure you don't have a mistake. Right. Do the last broadcast address. Can you do the last broadcast address first? Yeah. So if you want to know the next network address is add the magic number, right? So 24 plus 8 is 32. So that means that, yeah, correct. Now you can fill up the first and last usable very easily. Okay. The rest also, as you see the how Noel is doing, you should do that way. It's easier. Yeah. Correct. Your last usable for the subnet 3, you make a typo there. It's not 1688. Be careful with typo. Yeah. All right. So you're done. Okay. Okay. The rest, Farah, did you and Calvin, did you see Noel how he did just now? Okay, that's
Yeah.
the good way to get the magic number and then do the subnet address and then do the broadcast address. Then you can fill in the first usable and last usable. Okay.
Question.
Yeah. Which one?
The one in the broadcast address. Subnet number 3. This one.
Yeah. How do you get that? Yeah, because we only take the first 4. Actually, there is a continue again because the borrow bit is 2 power 5 actually, 5 bits borrowed, right? So that means the formula here it should be 2 the power of 5. That gives us how many subnets?
32.
32. So that means the number of subnets should be 0, 1, 2, 3, and so on until 32 subnets altogether. So after 3, what is the next subnet for? What is the subnet address for the next subnet is, because the magic number is 8, 24 plus 8 is, sir?
32.
Yes, 32. So the previous address is the broadcast address for subnet 3, which is 31.
31.
Yeah.
Okay, understand.
One bit. Complete the testing of the new subnet mask.
Question.
Yeah. Okay.
About the 6 usable hosts. How to find this one? 6.
Number.
Question 1, number 3.
6 usable hosts.
Yeah. How
Yeah,
to
the
find
formula
it?
is there. Formula
Okay.
is 2 power n minus 2. Minus 2 because the n means the remaining number of bits. So you have 8 bits.
Okay.
All right. So where n equal 8 minus 5 bits borrowed equal 3. Right? Because you borrow 5 bits. So remaining number of bits for the host is 8 minus 5. You have 3 left. So 2 power 3 is 8. 8 minus 2 is 6. Is it okay? That's why we,
Oh,
yeah.
okay.
Right. So that's formula to get the number of usable hosts. 2 power n minus 2. Minus 2 because the network address, you cannot use it for host. Broadcast address, you cannot use it for host. Okay, so 2 address we cannot use for host. Because here we ask usable host address. Usable host address means host address that you can assign to computer. Okay, the network and broadcast address you cannot assign to the computer. So minus 2. So even though actually we get 8, sorry, not 8. We got yeah, 2 power 3 is 8. We get 8 host addresses. We minus 2, so we only have 6 usable host address that we can assign to computer.
Okay.
Alright.
Two power.
All right, so for question 2, Kelvin, he needed to find out the binary part of the 240. It's already given, right?
5, 4.
So Kelvin had to, in order to know how many bits he borrow, he converted the 240 to binary. So let's do that. If I got 240, how many bits? So you can see 4 ones and 4 zero. The 4 ones, we know that subnet mask, the ones belong to network part. Since we are originally given the host IP address is this, we know that it's a class C, so we know it starts from /24. But given that 240, that means we have borrowed 4 bits, because 240 of subnet mask we put it into binary. We see that there are 4 ones. We know that we borrow 4 bits, right? So using the formula 2 power n, n being 4 bits, 2 power n, which is 4, 2 power 4 give us 16, right? 2 power 4 give us 16, right? If you do the calculation, 2 power 4. So that means we can, with the 4 bits borrowed, we can actually create 16 subnets, right? Then we know we borrow 4 bits, then only remaining 4 bits for the host part. So usable number of hosts for the number of host bits per subnet is actually is 4, because 4 bits taken by network, 4 bits remain, okay, for the host. And using the 2 power n minus 2 formula, okay, we get 14 bits, sorry, 14, not 14 bits, 14 usable host address, right? So it's the same thing, but different way of asking the question to you guys. But as long as you understand the concept, you'll still be able to answer. Okay. All right. So the prefix 28 because borrow 4 bits, right? So that's correct. Wait, hang on. Subnet address for this IP address. Okay, hang on, because this, where does this fit? Calvin, where does this address fit? In which subnet does it exist? You have to figure that out. In which subnet does the address 210 belong to? Cannot be the first subnet. Remember, how many subnets we have? 16. So this IP address of 210 exists in which subnet? And then what is the subnet address for that subnet? Okay, to answer the subnet address for this IP address. How do you find out? First of all, can you convert the 210 into binary? 210 in binary is what?
One one zero one 0010.
Right. Right. So you can look at that. Since we know the 4 bits belong, the 4 bits 1101 is the part of the subnet, right? Part of the subnet. So let's plug it in here. 1101. Sorry, not here. Here. 1101 only. I'm interested. So let's give us subnet number 13, right? Subnet number 13. Subnet number 13, what is the subnet address? So, as usual, magic number. What is a magic number? You borrow 4 bits. At that position, what is the magic number?
16?
Sorry?
16.
16. Right. So if 16,
32.
so 0 plus 16 plus 16. 13, right? 13 times, right?
Oh, need to count until 13 times, like that.
Yeah. And what is that subnet address? Yeah. You do that, and then you figure out for me.
Okay,
Okay, keep reading.
208 only.
What is it?
Only
200?
208.
208.
Not enough.
So 208, right? So that is the subnet address for that IP address. Can you see that? So if your answer is getting the magic number, you add it until you get this one, 13, until 13 times, then what number you get? 208.
Yeah, 208.
So 208. That's a subnet address for that. You get it, yeah? You got it already, yeah? So once you get the network address, the next one is 208 plus 16. What is it? Yes, that's 20. First usable is the next IP. The first address for this subnet that's usable is the one after 208. The broadcast address is here.
So if the broadcast address is there, need to do the broadcast first.
Yeah, because then you know the last usable. The first usable is usually the address after the subnet address. So what is the next address after subnet address? That is your first usable. So it should be 20. Next after subnet address, if subnet address is 208, the next address will be
209.
Yes. So that's your first usable. So 209. Okay. Then to find out what is the last usable is the address just before broadcast address. So in order to find out what's the last usable, you find out the broadcast address first. The magic number is 16. So 208 plus 16 is the next subnet address, which is
16. 224.
Yes, 224. So the address before that next subnet address is your broadcast address.
Oh, okay.
The next one after that is the next subnet address, 224. So broadcast address is the address before that subnet address, 224. So it will be the next subnet address plus the magic number 208 plus 16 is 224. That's the next subnet address. So the broadcast address of the previous subnet address is the address before the subnet address, which is 22. If 225 means it's the address after the next subnet address, we want the address before the next subnet address. So your broadcast address will be the address before the next subnet address, which is 224.
224.
So
the
next broadcast address is
223.
Yes. 223. 223, not 224. No, the broadcast address. Your broadcast address should be 223 because the next subnet address is 224. Yes. So that means your last usable is, yes, 222. Got it now. Yeah. The magic number is used to get all the subnet address one after another. Okay. To get the broadcast address, what is the address for the next subnet address? So normally you get the subnet address, you get the broadcast address. Or you get the subnet address for this IP, get the next subnet address, then you get the broadcast address for this IP. And then once you get the subnet and broadcast, easy for you to get the first usable and last usable host address. That's what we've been doing. Okay? Alright, huh? Any question?
So to find the last usable is to
in the broadcast first.
in the broadcast.
Find the
Okay.
broadcast, get the next subnet address first. Okay, and then the broadcast is the previous address before the subnet address. Let's say This is the current subnet address.
Okay.
So the next subnet address is plus the magic number, which is 16224. So this subnet address, broadcast address, will be the address before the 224, which is 223.
Oh, okay.
Yeah. So then once you have this, once you have that, then you can get the first usable and last usable quite easily. And how do you get this 208? Because from the 210, you convert to binary. Because you said the first 4 bit is subnet bits, so you convert that 4 bits. You get 13, right? So that means this host IP address is within the 13 subnet. So all you need to do is the magic number until you get 13, and that is your subnet address.
And then the subnet address added by
The
16.
magic number to get the next subnet address to get the broadcast address. The next subnet is 224. Okay, so the broadcast for this subnet is 223. So then easy for you to get this one, first usable and second usable. To confirm, look at the address 210. It's within the range, right? After
Oh yeah.
210, it's within that range. Right? You double confirm already.
Okay, noted.
Okay, so Noel, looking at the question 3 topology, he says that, yeah, there's 2 interface on the router. Sorry, here. Hey, how many subnets needed? Yes. Noel, you see one network here, one network here. Don't forget the point-to-point between the routers is also a network. Yeah, Noel? Don't forget, this part, router 0 to router 2 is one network also. Router 1 to router 2 is another network also. So those 2, and then router 0, other interface going to the switch 0 is one network. Router 1 going to switch 1 is one network. So there are 4. 1, 2, 3, 4 networks. So 4 subnets.
So each network equals to one subnet, like that?
Yes, because subnet is basically just subnetwork. So it is a network on its own.
Okay.
Yeah, the reason why we call it subnetwork because we're doing subnetting, we're dividing the network. But once we divide the network, each network we create is a network on itself with its own network address or subnet address and its own broadcast address and its own range of usable host address. So yes, actually each subnet is a LAN, is a network. So here we see 4 subnets or 4 networks. Yes, Kelvin. To get 4 subnets, you need 2 bits to borrow. Because 2 power n is 4. So ngam fit like this one. To get 4 subnet, you borrow 2 bits. 2 power 2 is 4. So you get 4 subnets. Correct. So this is a slash. You can see the network given 192 is /24. So this is a class C network /24 network. So if you borrow 2 bits for network pairs, how many bits left for host? The host part is 8 bits. So if you borrow 2 bits for the network part, for the subnet part, how many bits left for the host? 8 minus 2. So your n will be 6. Okay, so the formula for usable host addresses per subnet is 2 power n minus 2. So 2 power 6 minus 2. You get how many usable? Yes, 64 minus 2, you get 62 usable host addresses per subnet. So Farah, how do you get the 6 again? Why 2 power 6? How do you get the 6?
From 8
Minus
minus 2.
2, yeah. Because Kevin put there already 2 bits borrowed. So 2 bits borrowed, add minus 2, left 6. So the formula is 2 power n minus 2, you get 62 usable host addresses.
The 8 is what again?
The last, because it's a slash 24.
Okay.
Slash 24 network. You can see on the diagram it says 192.100.2.0 slash 24 network. So slash 24 network means 24 bits belong to network part. So if 24 bits belong to network part, how many bits belong to the host? 32 minus 24, IP version 4 is 32 bits. So if 24 belong to network, how many left belong to host? Better. If 24 bits belong to network, how many bits left belong to host?
I think 8.
Yes, 8, because 32 minus 24 is 8. So
Yeah.
that's why you 8. Then you borrow again 2 bits. So from the 8, you borrow again 2 bits. So left 6, right?
6. Yeah.
That's why you use 6 as n to calculate number of usable host address.
Okay. Okay.
Yeah, because at first it's 8 bit belong to host, but because you subnet, you borrow 2 bits, so only left 6 hosts. Whatever gain you get for the network part, you will lose from the host part. So the network part borrow 2 bits, so you only left 6 bits left. Why we start with 8 bits? Because our address is slash 24. Yeah. So if your network is slash 24, means 24 bits belong to the network part. Because we're using IP address 32 bits, so 32 minus 24, that means host have 8 bits. Okay?
Okay. Noted.
All right. So once we have the borrow bits 2 bits, so 24 plus 2 is 28, right? Sorry, 26. So in order for Novel to compute the subnet mask, he has to look at the binary part, right? So the binary part, if you borrow 2 bits, means programming here. So from 8 bits, 2 bits belong to network part. So 2 bits are 1, 1. And then the remaining 6 bits belong to host is all 0. 2, 3, 4, 5, 6. Okay, converting back to decimal, you get 192. So that's why the subnet mask is 255.255.255.192. Okay, so basically it's like this in binary: 1111 1111 dot 1111 1111 dot 1111 1111 dot 1100 subtract 0000. So this part is the, oops, sorry, shouldn't use that. Highlight. That part is the 192 part. Before you borrow, it is all 0. But once you borrow, it becomes, you borrow 2 bits. It becomes now 1 1. So now from 0 become to 192. Okay? So fairer? Yes. Subnet 0, Subnet 1, Subnet 2, Subnet 3. Okay. What is the first subnet address? You follow back the address given here, up here, 192.100.2.0.
5, 6, 7, 6.
Okay, this one, this address, the original one, 192.100.2.0. Now, we borrow 2 bits. So what is the prefix? It's no longer 24. We borrow 2 bits. So 24 plus 2 becomes, we borrow 2 bits, right?
26, yeah.
Yeah, 26 / 26. Now, what is the magic number? That last bit here, I highlight. What is the magic number there? In that position, what's the value of that one? Very easy if you're not sure. Calculator again. So it's 1000000. What's that? Magic number? 64.
64.
So to use the magic number, you just simply type 192 dot 100, because that remains the same, dot 2 dot magic number 64, and then prefix /26. Okay, the next subnet address is just same 192.100.2. Then 64 plus 64. Plus the magic number again. 64 plus magic number. 64 plus 64 is, yes, /26. Then the next one, same thing. 192 128 plus magic number 64. Yeah, /26. Now, once you get the subnet address, you want to do the broadcast. The broadcast is just the address before the next subnet address. So the broadcast address for subnet 0 is 192.100.2. The address before this address. Dot 63. Correct. Now the next broadcast address, fill up all the, no need to, the broadcast address do not have the prefix, so don't write the prefix for broadcast. Okay, just leave it like that. Yes, the next broadcast address, same. Since you have the subnet address, you just do, okay, dot 1 2, yes. Okay, and then the next. Yes, so the next one, you have to do the magic number to get the subnet 4 address, so that you know this one. 192 plus 64 is, yes. Oh, is it? Yes, I think so. 60 plus 64. Hang on, let me just confirm. Yes, that's correct. 255. All right. So now the host range is the first address after subnet and the until the next address before broadcast. So it's 192.100.2. Next address is after 0 is what? Next address after 0. Yes. Dash means a range, range until the address before the broadcast address. Which is, I think you should write the whole address. The full address. 192.100.2. Yes. And continue. Okay, continue. The next one is like that also. 60. Yeah. Exactly. Yeah. So the key here is get the subnet addresses done, get the broadcast addresses done, then the host range will be very easy to do. All right, you're done. Well done. So everyone know that this, what we're doing so far is the subnetting. So next week, we're going to do the VLSM instead. That means I'm not sure, is it the VLSM or the plus, or subnetting class B and C next week. All right. Okay, so please do the previous one. If you haven't, there's still some you haven't done for the tutorial 7. Just complete it. I will mark it. Okay. All right. Thank you everyone for today. We are a bit over the limit of our time, so I'm sorry about that. But I had to leave it like halfway. So at least we know how to do subnetting for class C. Okay, class C address. Okay, thank you everyone.
Okay, sir. Thank you.
All right, thank you very much.